Hi, it's Gary Kayye. We're here at InfoComm 2017. I'm here with Guy Russell at the SiliconCore booth. Guy, you guys have a product out there in the front. You've nicknamed it Z.A.C.H, and it's really not a product. Well, I guess it is a product. It's a new driver technology that's going to drive the LED displays across the whole product line.
Yeah, we've got basically an evolution to our common cathode LED drivers. And one of the big things that we found over the years of trying to do this is trying to create a uniform image with multiple light sources, the LEDs being the light sources, trying to create that uniform image when the LEDs are being asked to be really dim, basically at the low end of their luminance. And traditionally what happens when you're at the low end of the luminance, you see some variation in the impedance based on traces.
You lose the uniformity basically across the display.
Correct, and so we can't create the same sort of uniformity we can at high brightness at the low brightness end. So what we've done is we've mapped, basically actively mapping the impedance variances from pixel to pixel, from diode to diode, in a way that we can now create a uniform image all the way down to almost the very end of the grayscale. So we're getting roughly about a 14-bit from perfect uniform image at minimum brightness to a perfect brightness at maximum brightness. We're getting about 14 bits of dynamic range with this new driver.
And this driver is HDR compatible, obviously, with the range that you're going to have. The big value that, well, first of all, it's going to go in the entire product line, including the Lisa, which is due to ship sometime later this year.
Correct.
Which I'm a big fan of the design that you have, where everything's on one substrate, for lack of a better term, or one PC board. This driver technology is mainly because the biggest problem that people have with the biggest problem that companies have with LED is when you're showing really dim stuff, not when you're really showing the bright stuff, and then tracking that across all the panel, right, as well as all the images at all different levels. So what you've done is focused on the 255, the 0 to 255 scale. You focused on the bottom of that to make sure you're covering and you're increasing the range of your bottom rather than the whole scale itself. So I think what I read was, or heard somewhere, was you were sort of, I don't want to say crushing blacks, but that's kind of the term we used to use.
Well, you have a choice. You're either going to crush your blacks, clip basically when you hit that point of non-uniformity anymore, or you're going to allow yourself to go down there, but now you're not going to have that uniform gray or darker blue, darker red, darker greens because of that variance in impedance. So
you went from 13.
Roughly we were around 13 out of a 0 to 255 scale where we'd start losing uniformity to now around 3.
I mean, that's a substantial improvement. You're talking about a 70% improvement in your low end.
It's huge, and you know, typically we're around 1 to 2 nits or so with the previous technology as a minimum uniform brightness. Now we're at 0.1.
And that will help you too. I mean, I'm not obviously as technical as you, but it seems to me that would help you in environments where you have to turn down the brightness of the display itself and run it that way all the time.
Absolutely.
Increase your range, because when you do turn on the brightness, you do automatically inherently decrease your range.
Absolutely, and one of the other things that's part of Z.A.C.H is that we're able to make that a more uniform scale when we go from the bottom end, you know, the 1, 2, 3s, all the way up to the 255. Previously, that scale wasn't exactly linear. Yeah. Now it's very linear, so we're very consistent across that whole range. Big improvement in mapping to exact, accurate colors, which is important in the HDR world.
Yeah, and especially and scalability-wise. So when you grow bigger, you're still consistent across that range. So I actually understand that, and I think it's going to be really cool to watch that develop. And I'm excited that I kind of found this as I was walking by. You can check it out at SiliconCore-technology.com. Or no, is that
SiliconCore.com?
SiliconCore.com. I was looking at the LinkedIn address, SiliconCore.com. And of course, you can see information on Lisa as well, which is Lisa's an LED technology. Panel technology where you actually have the drive, where you actually have the electronics and the panel itself on one PC board. I shot a video of that and I've talked a lot about that since ISE, since I found it at the ISE show. So you can see all that. You can Google SiliconCore, SiliconCore, on our website, and you'll find that information. Guy, I really appreciate your time. Thank you and congratulations.
Thank you, Gary.
And thanks for watching. You can see all of our coverage here at InfoComm at ravepubs.com.